Hi everyone, this is our Space Exploration Challenge project. Today we're going to be presenting our research project regarding transportation and wheel development for lunar exploration missions. So the Apollo lunar missions in the 1960s and in the 1970s were absolutely groundbreaking achievements in space for the entire humanity since we made our first steps on the moon. These missions faced diverse challenges and offered quite a bit of lessons to continue to influence modern science and technology up to date. One key area of focus is the development of tires for lunar vehicles, which were definitely essential for navigating the moon's harsh environments. Um, and so during the Apollo missions, General Motors were the ones who designed this mesh out of metal tires that performed well under the moon's extreme conditions. It provided necessary traction and durability without the risk of deflation. However, as we look ahead to upcoming missions like the Artemis mission, which one of the main objectives is to establish longer term presence on the moon, these tires' durability remains one of the main challenges. So in order to support heavier loads, longer missions, and a more rugged terrain, the need for a durable and advanced tire has become absolutely critical. And so this research will be focusing on how to overcome these challenges and contribute to the development of a more reliable technology that will enable a more sustained human exploration and eventual colonization of the moon.
Well, to start talking about the different types of tires, we need to talk about the air-filled and airless tires. These two types of tires have different technologies, different principles of operation. The first one, the air-filled, are the common tires that we use here at the Earth. For example, in our vehicles, in our trucks, airplanes, a lot of transport, a lot of transports. These tires have been developed since the 20th century, the 19th century, and they are good for air applications. And they have the particularity that they are very easy to to develop, and they only require a low technology to be operational. And one of the disadvantages of these types or air-filled tires is the puncture, deflation, and damage that a lot of that like the terrain, the rocks, or objects of the road could have damaged it. So in the lunar fields, we need a tire that could be resistant to punctures, resistant for shock, resistant for all these types of damage that the moon could offer to the terrain. So there is another a solution of this, and this is the airless tires. The airless design does not require air to be inside of the tire. Instead of this, it uses like a range of material that could be plastic, could be metal, could be a different material that it's inside of the tire. So, in applying these materials inside the tire could benefit by the way that the tire could absorb the shock effectively, and it can resist all the punctures, the the penetration of a lot of external objects, and it could be very more um, reliable. Go ahead, please. And for this, for achieving these tasks, we have developed a prototype of a metallic foam tire for these lunar environments. What is the metallic foam? Metallic foam, it's in a very new material developed in the mid of 1960s, approximately. It consists of a metal bar, metal material that have like small holes, small circles to make a structure like a bone, for example. Have a lot of porous structures, and this arrange um, experiments a lot of resistance, a lot of energy absorption. It's very light, and it combines a lot of advantages that we can implement in a tire. And for example, here's image of a test in an experiment taken by the NASA. They 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 broke 3 sheets of metal and one of metallic foam and 2 from a honeycomb arrangement of metal and plastic. The experiment reveals that the metallic foam experiments a very good shock absorption, a lightweight operation, and it, it shows the um, the advantages of using this material instead of another traditional materials. And we can use this material to construct our new wheels for the lunar rovers and the lunar vehicles. Here it's a prototype tire from Brixton. We can note that it occupied a lot of space for the metal spokes to support the outer contact layer. Our idea wants to redesign this this concept and apply the metallic foam as a shock absorption as a shock absorption layer that could benefit the operations in the moon. So, for example, if we are in a very rocky terrain and we have an accident, for example, the tires could absorb this impact and could protect the crew inside of the vehicle or all the scientific equipment or all the stuff that they are using to explore the moon terrain. And so, moreover, we want to implement a modular section of the tire. That it means that it could, if it needs a reparation or a substitution of one part that had been damaged, we can only remove that part of the tire, and the all the other parts of the tire could be used in another missions or could be repaired more easily, more effectively.
Well, now for the proposal that we made, it consists about the airless tire integrating metal foam. That is, the development of an airless tire is using metal foam as a base material. And so this solution will provide greater durability and resistance to the extreme conditions of the lunar surface, while it's reducing the risk of punctures or mechanical failures. Also, airfoil tires offer effective cushioning, but are vulnerable to punctures. So, in the other hand, our airless tire provide durability and strength, although they may lack the flexibility needed for certain terrains. So it's proposed to design incorporates a metal foam structure with special groups to provide traction, and the flexibility and strength of the material will allow it to overcome the challenge of the lunar terrain.
Well, in this project, we are facing several significant obstacles due to the unique condition of the moon. And first, let's talk about the challenging lunar terrain. The moon's surface is made up of rough, abrasive dust, along with craters, rocks, and steep slopes. These harsh conditions make it hard for vehicles to get good traction and stay stable, so advanced wheel designs are needed to move through these obstacles safely. And another major challenge is the extreme temperature on the moon. Due to the lack of atmosphere, temperatures fluctuate drastically, reaching up to 127 Celsius degrees during the day and dropping to minus 173 Celsius degrees at night. This intensive variation creates enormous stress on equipment, potentially leading to malfunctions. So effective thermal control systems are crucial to ensure the vehicles and other components remain functional and protected in these conditions. The next slide, please. Now regarding energy use and adaptability, lunar vehicles need to prioritize energy efficiency and minimize mechanical wear. This includes using robust suspension system and abrasion-resistant material to handle the rock, dusty terrain. Vehicles must be designed to withstand this harsh condition, making adaptability essential for existing mission duration. And finally, we need to consider a full for lunar transportation. Sustainable power resources are essential for environmental viability on the moon. Advanced batteries, fuel cells, and systems like the isotope Brayton cycle can provide continuous power without external combustion, making them ideal for long-term exploration missions. This approach minimizes reliance on Earth's resources and ensures that vehicles can operate effectively for extended periods. In summary, overcoming these obstacles is vital to ensure successful exploration and safe.
Well, then to finish our presentation, we conclude that as lunar exploration advances towards longer missions, such as the Artemis program, the development of durable and efficient technologies for transportation becomes fundamental for its viability. And then metal foam, it's becoming a promising material in the scene, since its lightweight structure, high resistance to impact, and thermal dissipation components make it to a great choice for further developments in order to create better tires for lunar missions. And overcoming challenges like energy efficiency, a capability to terrain, and the thermal control is crucial for a sustainable lunar explorations. So continued innovating in materials and design. This research project aims to support the foundation of an advanced transportation technologies that will allow lunar missions to research the maximum potential. So thank you. That was all, and bye.